How was everyone else's weekend? Anyone get up to anything exciting? Oh, damn. It's never fun to have to work on a weekend. Oh, nice. Auckland trip for some music for a music thing. Nice. Family stuff still better than doing nothing. Oh, what kind of car, Jordan? uh, is it a Ford Laser or is it a TRD laser? Stitch up, Jack. Uh, uh, what kind of hunting, Tyler? Like what were you after? Oh, nice. Did you get any or not this trip? Okay, well, let's get into sucks. All right, so we'll get into a bit of a revision. So we'll recap some key points from last week. So we focused a bit on ASNZS 3000 Part 1 and the fundamental principles. So the aim, just have a little bit of a refresh over before we get into Part 2. So when we talked about part one, so it covers the general safety principles that apply to all installations. So this is the core. So we use this to develop the rules in part two. But sometimes part two doesn't cover everything. So we have to check in part one. One example is a lot of low voltage HVAC controls. Doesn't always fit into part two. So they have to look at part one to figure out if it's safe or not. So part two is the installation rules. So they contain detailed technical requirements, so actual measurements and values that we can apply. But understanding part one helps to ensure compliance when we look at part two. So if we don't quite understand why something's in part two, we can look at part one and it kind of gives us an idea why it's there. So the 14 fundamental principles ensure electrical safety and compliance. So example 1.5.3. Protection against electric shock includes both basic protection, direct contact, and fault protection or indirect contact. 1.5.9 is about protection against overcurrent, so it ensures circuits don't overheat and cause fires. And then you got 1.4.14, which is protection against external influences, so it ensures installations can handle environmental factors like heat, moisture, and mechanical damage. So Linux Navigate 3000 is essential for our electricians because it's our go-to first reference when we're doing installations. So the contents page and index are the best tools for quickly finding the relevant information. So it's not just for training, it's critical for real world electrical work and EWIV regulations exam, which you guys will have to sit after you pass year one and two. So, if anyone hasn't talked to you about the way the process works for your apprenticeship theory wise, so at the end of the first year, you now have a capstone, much like year two. Then you go into year two. After year two, you set a capstone at the end of year two. And if you pass year one, you get into year two. And if you pass year two, you get into the year three, which is split up into two halves. The first half, as far as ETCO is concerned, is your year three theory. So you'll do the last bit of your theory training before you sit your theory exam. And you can only sit your theory exam after you've completed the first half of the year. Well, good, Daniel. Thanks for joining us. And then, yeah, so after you've done your theory exam in year three, you then go on to the second half of the year, which is all about the regulations. So, learning how to use the Act, ESR, and 3000 to find information, basically, learning how to drive the vehicle that is the regulations and safety rules. So that way you can find the answers you need to in your theory exam. So, yeah, first half of the year three, theory, sit your exam. It's best to sit your exam. You can delay it, but it's best to sit your exam straight after you finish the theory course. If you go to book your exam and you find there isn't a slot, this is for later down the track, you can email Aspec, who administers the exams, and you can ask them to open up another slot. Because usually there will be a certain amount of slots for electricians, midwives, plumbers, etc. But if a midwife or a plumber seat hasn't been taken up, they can open it up for another Sparky to do their exam. And then same for your regulations. So after you've done your regulations course, you've got 80% attendance. You can then set your regulations exam. One other prerequisite is that you've done your block course as part of your theory as well. So that's what you've got to look forward to in year three. Cool. So here's some revision questions. So what are the two main parts of ASNZS 3000 and how do they differ? Okay, a bit more detail than just one and two. So part one is what and part two is what? Yeah, Sasha pretty much got it there. So part one, yeah, is your fundamental principles, and part two is your installation rules. So part one applies to all electrical work and provides general safety rules, and part two contains detailed situation-specific requirements. So why is it important that we understand the 14 fundamental principles before applying the rules of part two? So it's important that we understand yeah, because part one applies. So the fundamental principles set out the foundation for safe electrical work. So they're the baseline guides, like Andy says. Or part two is rules to follow these principles to ensure installations are safe, compliant, and functional. So example, protection against overcurrent in 1.5.9 is in part one, is the basis for selecting fuses and breakers in part two. So when working on site, how can you quickly find a specific regulation in 3000? Assume you guys aren't working with a PDF. Assume you've got a big book on site and you've got no internet connection. So you can use the contents page for an overview of the topics, and then you can use the index to find a specific term or requirement. So if looking for earthing rules, checking the context first, and then using in-text to locate references throughout the document. So today we're just focusing on part 2. So it contains the detailed technical rules for electrical installations. So the document is something you'll use throughout your entire career. Knowing how to navigate and apply it will make you a better electrician and ensure you're always working safely and within regulations. You won't always know, like be able to just rattle off, okay, this is in this section of part 2, and this is the blah blah blah. Occasionally you will come across a situation that you haven't done for 5 years, 6 years, and you're like, oh crap, what's the measurement again? How do I do this again? And there's nothing wrong with that as long as you know how to use the book itself. That's what we care about, the fact that you're able to use it, and then because you can use it, you can follow it and be compliant. So beyond just learning how to use the document for your job, it also is the start of something even bigger, your preparation for your EWIB regulations exam. So one of the key areas of the exam is understanding the rules set out in AS NZS 3000. So the time you invest now in learning this document will pay off later, not just in your day-to-day work, but when you sit that exam. So if you can get comfortable using AS NZS 3000 now, you'll find studying for the regs exam much easier. So today's lesson is a big step towards that goal. So before we get into it, I'm going to post into the chat. Cool. So here is a Google Drive link. So if you don't already have a copy of 3000 as a PDF, you can jump onto that link and use it. And that way, as we go through 3000 today, you can follow along at the same time. Cool. So like we've talked about, part 2 contains specific technical rules for different installations. And unlike part 1, which applies to all installations, part 2 is more detailed and situation specific. So everyone should be able to see the screen. So I've grabbed a PDF version of 3000 here. So we jump down, a whole bunch of legal jargon, preface. This is starting to be a bit slow today. Cool. So we come down to the contents page. Oop. It might being difficult today. So here we've got all of our contents page like we looked at last week. All your appendices and all of your different sections. Cool. So where would you find the required depth for a category A underground wiring system? So downloading 3000 2018 off the EWRB, it may have been because that was the first one that came up. I don't know why you should have only been able to access 2018. All good, Levi. See if you can grab that link that's just in the chat above and go to that. Yep. Cool. 3.10. Cool. Let's go there. Oops, we've gone too far. Section 5. Oop. Section 3. Cool. So now we can go down. It's much quicker to do it with an actual hard copy. So what's the required depth for a Category A underground wiring system? If you guys can get there before I do. Wiring systems. So we're looking for find the required depth for a Category A underground wiring system. So if we're looking at Category A, so external to a building, a Category A with no surface covering or less than 75 mil of thickness of concrete, we're at 500 mil. That's the minimum depth of cover. What does that mean when I say minimum? What do you guys think it means when I say minimum depth of cover? So when it says minimum depth of cover, it means that the top of the wiring system can't be above 500 mil. So 500 mil of cover means to the top of the wiring system or the wiring enclosure, which means you actually have to go down deeper. And usually your cable for a neutral screen, it's probably going to be at least 50 to 100 mil thick, depending on the size. So that's why we dig our trenches down to 600. Go further down, shows. And then you need marker tape at 50% of the depth of cover. So if we go down here, if it's 300 to the top because we've got concrete, that means at 150 depth, we need to have marker tape. If you see down here, you've got 500 mil to the top, 50 mil of sand, 50 mil of sand, and at 250, you've got marker tape. Cool. So what about the distance from a shower or bathtub to a PowerPoint? in 6. So yeah, dam situations, 6.2. Cool. So then, because we're using the PDF, I'm going to input 6.2. And then yeah, Andy reckons he's got it. Let's. Yep, cool. Yeah, socket outlets shall not be installed within 0.3 meters of a floor of a bathroom or laundry or other similar location. Yep, so zone 0 and 1, not permitted in zone 1 or 0. Zone 2 must be of the automatic switching type incorporated in a shaver supply or protected by an RCD with a fixed rated residual current not exceeding 30 milliamps and enclosed in a cupboard that maintains the enclosure of the socket outlet during normal operations. And then zone 3, protected by an RCD, supplied individually as a separated circuit or supplied at safety, extra low or protective extra low system. Cool. So what are these zones? So you scroll down. Here you've got your tables. Make it nice and easy. And down here, so this is baths and showers, zone dimensions. So if we look at zone 0, it's in here, zone 1 in here. This is zone 2 here. So 600 mil from the edge of the water container, the internal edge, not the external, because the edge may be 200 mil thick. It's 600 mil from where the water edge is. You can get elevation, so bath without shower or fixed barrier. So this is the tub down here. This is your zone 1 going all the way up to the ceiling. Zone 2 extends to 2.25 meters from the floor, and zone 3 is basically everything else. Here you've got a shower with basin without barriers. So you got zone 1 extends out to 1.2 meters from the shower head. Zone 2 is 600 out from that, and zone 3 is everything else. So yeah, here, fixed plumbing shower connection. So yeah, it's 1.2 meters out from the wall or from the fixed shower. Zone 2, 600, but only to 2.25 meters from the floor. And then zone 3 is everything else. So Australia is actually 2.5, whereas NZ is 2.25. Same here for a bathtub. This is a bath with shower without barrier. And this is bath. Um, come on, go away. Yeah. So baths and showers without shower with fixed barrier. And then there's another one for laundry tubs further down. So that's how it is working your way through ASNZS 3000. Cool. So now that we've started to learn how to navigate, we'll break down part 2 into the 7 main sections. So we looked at them before. Here we go. Sink basins and a laundry. So that would be damp situations. So, so bath showers and fixed water containers. So we go back to 6.2.4, and then we'll go to point 6. So switchboards may not be installed within any classified zone. So nothing changes as far as the rules are concerned in terms of distances. But here you go. Cool. So this would be a laundry tub. So other fixed water containers with a capacity not exceeding 45 liters and fixed water outlets. Cool. So your zone 0 is the tub itself, and your zone 2 is 400 above and 0.15 to the side. So switchboards and laundry, which was there first, the laundry or the switchboard? Because a lot of times what happens is a switchboard is existing and they build a laundry around it. It used to be that it was okay because the laundry didn't they didn't always have dryers. So a dryer was a luxury item and wasn't in every household. But rules now are just no. If it's existing, if you have to work on it, you have to bring it up to compliance. So you have to relocate it. Um, yeah, so you cannot put a switchboard in a laundry because it is a classified zone. Um, but also because of the moisture and a laundry, it's just not worth it. But yeah, if it's within a classified zone, so if we look at water containers of a laundry, technically you could put one in, but I just wouldn't. It's best to put it in a hallway, or if they really want to, put it outside. For example, if there was a switchboard here on this wall and it was external, I would be convincing the customer that it would be a lot easier just to put the switchboard through the wall on the outside. Yes, it'll look a little bit ugly. Switchboard near laundry tub internal. Ah, again, what was there first, the switchboard or the laundry? If the switchboard was there first and they put a laundry in it, that's on the builder. If the laundry was there and someone put a switchboard in it, then that's not a very good electrician. Just the the main concern for the switchboard and the laundry is, have you guys have been into a laundry when a dryer's been running and there's been no extraction fan? How muggy and damp that room gets. So yes, in part two, you could get away with it because it's not a classified zone. But if you go back to the fundamental principles in part one, is it electrically safe? Is it protected against the ingress from moisture? And unless you use an IP rated switchboard, and even then, there's a chance that the jib could get damp and then that leak into the switchboard and rust the metal of the switchboard. I would rather put the switchboard, so my preferred locations: hallway, garage, external to the building. You can't put it in a cupboard, at least not in a domestic setting. Be a hallway, garage, or outside. Those are generally your best bets. Um, Not in a kitchen because, again, steam from cooking. So yeah, your best bet for switchboard locations are somewhere where there's plenty of ventilation. It's not going to be have to deal with moisture or any external heat sources or be exposed to the elements unless it's designed for it, like an external switchboard. So internal garage is fine. Yeah, it's not ideal. Yeah, I mean, internal garage. So, for example, my house, I have an internal garage on the ground floor, and that's where our switchboard is also where the solar battery is. But that's because that's where it was originally put. It's also the closest point. Well, it's not the closest point to supply, but it's out of the way. A lot of modern homes are built with the switchboard either in the stairwell, hallway, or in the garage. It's not too often now that you'll see a combination meter switchboard installed new outside. I've only ever done those as retrofit. But yeah, if you're doing solar installs and you've got to put a switchboard somewhere, um, I would be more inclined to, if the switchboard's old and you can't just add to the switchboard or you have to keep it separate, I would be inclined to put a um, switchboard outside, an IP rated switchboard, rather than me in the laundry. But that's just my preference. I avoid laundries other than just one single PowerPoint. Um, but I also like to run laundries with a fan that's wired with a current sensing relay. So basically, it's a relay that as soon as you turn something on, it senses the current that then switches on the fan in the laundry. You'll see it a lot in large housing developments. And they, as soon as you turn the washing machine or the dryer on, it clicks the fan on, and then it's got a run on of, I don't know, 5 minutes just to get rid of all the moisture in the air. Cool. So we'll go through each section uh, one by one and have a look at basically what you're trying to find in each one. Yeah, contents page. Cool. Cool. So section one. So this is still part one, is section one. So this is where you find your application, any reference documents, and the fundamental principles. Cool. Ah, and I just realized that you can. Okay. Oh, if you click on here, oh my gosh. How did I not know about this? Cool. So you and I are both discovering a new feature here of this PDF, is that if you go to say 250 for switchboards and you click on the 50, it will take you there. I shit you not, this is the first time I am realizing this, which is really handy for when you're doing any kind of homework or looking through it, especially on a computer. Cool. So if we go to section two, so it's the general arrangement, control and protection. So this section provides guidelines on how an electrical installation should be arranged, controlled and protected to ensure safety and functionality. So it covers switchboards, protected devices, and positioning of electrical equipment to comply with accessibility, load management, and emergency switching requirements. So a switchboard installed in a hard to reach location, such as inside a cupboard, behind stored items. So find me the reference for where it says you can't install it in a cupboard. So just some of you may have been in part 2018. So yeah, just popping the Google Drive link there again, just so you guys can find that and download the 2007 version. Cool. So everyone reckons it's in 2.9. So we'll jump to 2.9. And you guys reckon 2.5. So 2.9, 2, 5. Restricted locations. Yep. C. And cupboards, a switchboard installed in a cupboard or similar enclosure should only be installed in an area set aside for the purpose. Um, so yeah, 2.9 for 2 requires switchboard to be designed and located. Yep. Easy access. Cool. So near baths and showers. Yeah. So yeah, so basically it shall be installed in areas set aside for the purpose. So if we set aside a cupboard inside of a home and domestic setting for a switchboard, and we installed a standard domestic wall switchboard and a network cupboard in that network board in that cupboard, do you think it's a good idea? And why? So if we set aside a room for a cupboard for a switchboard. Uh, It was set aside, it was designed for it. We put the network board in there as well. Do you think it's a good idea? Well, for the network, yeah, I get that, Rex. Yeah, I get where you're coming from on that one. Yeah. Okay, my view on it is no, because yes, an area that maybe or similar inclusion only installed an area set aside for the purpose. So in cupboards, um, yeah, you can get harmonics on the data. I mean, you have to put them at a certain distance, but the reason you wouldn't put it in a cupboard is because you can't control what the homeowner does after you install it in there. So if you give them a cupboard and you put a switchboard in it, they're going to put shit in the cupboard. So even if you specifically set it aside and you say, do not put stuff in here because it's a switchboard cupboard, soon as they buy the house, they can do whatever they want, stuff it full of it, and you could say, not my problem. But if you have to come back and do maintenance for any reason, why is all this stuff in the cupboard? Why can't we get to it's the same when I was doing state housing maintenance. We had to get to the roof access. The roof access was in the laundry. The laundry was full of dirty clothes and clean clothes, and we couldn't get it in there to put a ladder up to get inside the ceiling for a couple of days while they cleaned up the laundry. But that is a completely separate issue. Cool. So let's go back up to the contents page. There we go. Cool. So section 3, we come down to section 3. Cool. So this is all about electrical wiring to be selected and installed, certain environmental conditions, expected load, and protective requirements. It also covers installation methods, sizing, and mechanical protection. So, for example, here we can find underground cables must be protected from mechanical damage using conduit or mechanical barriers. So cables must be correctly rated. Cool. Right. So one key thing to look at with this section is voltage drop. So let's go to 312. So, cool. So, here, the cross-sectional area of every current conductor shall be such that the voltage drop between the point of supply for low voltage electrical installations and any point in the electrical installation does not exceed 5% of the nominal voltage at the point of supply. So, the point of supply being the mains connection to any connection or point in the installation, 5%. So, what is that number? So, for a 230 volt installation, what is the minimum allowed voltage? What's the lowest voltage we can have in a 230 volt standard installation? So the easiest one is you take 230 and you divide it by 1.05, which gives you 219.05 volts. So about 219 volts is the lowest voltage you should have at any outlets or switches or light in your installation if it's a 230 volt installation. What about a 400 volt installation? Yeah. 380. 380 is the lowest volt drop we're allowed. So then we can take a look down here at section 4. So this section is how, yeah, so there is actually so they're required to provide you with a certain voltage up to the point of supply, and then from the point of supply to the for the lines, yeah, but then we've got to do ours. So yeah, the lines company are to the point of supply, and then we're from the point of supply to the end of the conductors. So yeah, so section 4, it outlines how electrical appliances, outlets, and switches must be installed to meet safety, operational, and environmental requirements. So, example, electric cooktops must be installed with proper clearance from surrounding materials to prevent overheating and fire hazards. And so, key requirements, so fixed appliances, uh, so hot ovens, hot water cylinders must have dedicated circuits to avoid overloading. Um, what about someone find the requirement for a freestanding stove connection? What is the reference and for a freestanding stove connection? Yeah, most of you guys saying 4.7.2. Cool. So we'll look at 4.7. So we'll go down to page 20. Cool. Switching devices. Point 2. So in New Zealand, a freestanding cooking appliance shall be connected to the electrical installation wiring by a socket outlet or an installation coupler. This requirement need not apply to built-in hobs and ovens, so it's only for freestanding. So that's one of the ones that a lot of people don't quite understand. So when you go to replace a freestanding stove, some of the old ones were hardwired. I've seen guys, oh, cool, disconnect the old one, put in the new one. Do you guys have any idea why this was brought into 2007? Why this rule might be put into the 3000 wiring rules? Actually, Thomas has it right, so that people can move the freestanding stoves to clean in behind them. Because what people would do is they would pull the stoves out, and if they pull too hard, they could rip the connections out, and then you have live conductors possibly because they've left the switch just hanging out in the open. So they can pull the stove out, unplug it, move it to one side, clean in behind it, do all that they need to do, push it back, plug it in, and it's good to go. So yeah, that was the main problem with the hardwired ones is that you also then had, if you didn't sleeve it properly, because a lot of them were, the cable was sleeved with rubber, like rubber hosing, or thin, old school corrugated flexible conduit. So they weren't very safe. And the old two-phase ovens, well, PDL made a two-phase, plug lead for ovens. Um, and when they had to install them with a single phase circuit, they just bridged one of the connections in behind the socket. Yeah, I saw a lot of those in the old state houses. So back up at the contents page. So now we've gone through section 4 a little bit. Cool. So then we're down to section 5. So this is a very critical section to look at. I would have a look at this if you get the time, just have a read through it. It's not a huge section. Yes, it's 40 something pages, but it is one of the most crucial parts of what we do because earthing is a huge safety feature as our electrical system. So this section explains the earthing methods, bonding, and fault protection to prevent electrical shock and ensure safe fault current dissipation. So metal enclosures and conduit systems must be earthed to prevent electric shock. And then there are some key requirements for bonding of bathrooms, swimming pools, and outdoor areas. Cool. Can someone find me the bonding rules for gas appliances and gas piping? Yes, I said gas. Daniel, 6. Okay. Most of you seem to be 5.6.2.3. Yeah, all good, Daniel. Cool. So we'll go to 5.6, potential bonding, because we know we're talking about bonding gas appliances and gas pipes. And you guys are saying point 2, point 3. So point 2, other conductive piping systems. Cool. Exception. Conductive piping systems associated with fire sprinklers, gas, water, or flammable liquid that are unavoidably in contact with the exposed conductive parts of wiring enclosures, cable components, or other electrical equipment shall be connected to such equipment by means of an equipotential bonding conductor. Cool. So this is only saying that when they are unavoidably in contact with exposed conductive parts of wiring enclosures, cable components, or other electrical equipment. So, for example, if they decide to use the Unistrut hangers that we've used for our cable tray, and they decide to then use that to connect their gas piping, cool. They need to bond the gas piping then. There's no, or that, for example, in a medical treatment room, if you guys have seen above the beds in hospitals, they've got the power outlets and gas pipes all coming out of the wall together. If you were to take the cover plate off, you'll find that there's just one big metal box behind there, and all of the gas and electrical conductors are fitted to that box to connect the power points. So that entire thing needs to be bonded. And then usually there's extra bonding up in the ceiling for the gas pipes as well. Or, for example, we have a gas stove that has electric ignition. It's connected to our wiring system, we need to bond it. And just having the, say, if it's a 2.5 inside of a 6 mil conductor for that ignition, that 2.5 is not big enough for the bonding. So we need to run an extra bonding conductor. Oop, oopa. Cool. So now we looked at, so we looked a little bit at dam situations. So it covers a little bit here. So it covers wet or hazardous environments and require additional insulation, protective barriers, and installation clearances. The section defines the necessary precautions for bathrooms, laundries, swimming pools, and outdoor areas. So, for example, if you're planning a bathroom installation, must include correct socket and switch distances from sinks, bathtubs, and showers, ensuring compliance with measurement requirements in Section 6. So, electrical fittings in wet areas must follow minimum clearance distances from water sources. Cool. So, in terms of refrigeration rooms, can someone show me give me the reference for if we can install a socket outlet inside of a refrigeration room? And one other thing to be aware of, guys, if you've got Sparkies coming from the UK, they will try and tell you that you can't put a light switch inside of a bathroom. In the UK, they don't put the light switches for bathrooms inside. They put them outside of the bathroom. Cool. So you guys all reckon 6.6.4.3? Cool. So we'll go to 6.6, jump down, 0.4, 0.3. Cool. Socket outlet switches and other accessories shall be designed such that provision is made to prevent the retention of moisture within their enclosure. Requirement may be satisfied by the use of socket outlet switches or other accessories and control gear having the required degree of protection. So if we look at 6.6.4.1 or 6.7 as appropriate, that are permanently sealed. So they have to be permanently sealed. So you can't just take a normal socket outlet or even some of the IP rated socket outlets and put them in there because they won't meet the requirement for being sealed against moisture and cold ingress. Because that's the other thing. Cold is a major factor for condensation. Cool. So back up to the contents page. Cool. So we looked at 6. Then we can look at section 7. So provides rules for non-standard installations such as hospitals, caravans, arenas, and construction sites, ensuring special environments have appropriate electrical safety measures. So, for example, hospitals require backup power supplies and isolated electrical circuits for life support equipment, and caravan park installations must follow specific earthing and supply rules. So on here, so if you look, you've got safety services, generation, isolated supply, low voltage installations, or extra low, high voltage, hazardous areas. And then you've got specific electrical installation standards. So it's basically a list of standards. Find me the standards that pertain to, and the reference in this that pertain to caravan parks. So basically, find me the reference to standard for the caravan park. So most of you have identified it's in 7.8. Cool. So we go to 7.8, section 7, page 35. Cool. Additional requirements. You reckon 0.3, do you? Transportable structures and vehicles, including their site supplies. So transportable structures and vehicles, including their site supplies, will comply with 3001. Yep. We'll just look down, just double check there's no. Yep. Another one's reference, electric fences, 3014 and 3016. Pretty sure it says it in that standard, but one thing to remember about electric fences, you cannot have an electric fence and a barbed wire fence in the same, basically you can't electrify a barbed wire fence. Why do you think you can't electrify a barbed wire fence? Yeah. Basically, because if for something goes wrong, you get stuck on it in a barbed wire fence, or yeah, you'll get stuck on the barbed wire, and then you'll just keep getting that and that and that. Yeah, it'll definitely harm people. It's not definitely not something you want to have happen to you. Cool. So now that we've had a bit of a tour around the book, I'm going to take. Cool. So here is a bit of an activity. Cool. So it's designed to help you apply 3000 to real world electrical installation scenarios. So it's to help you locate things. So for question 1 to 7, um, identify which section of part 2. And for questions 8 to 10, you'll need to provide a detailed answer referencing the relevant sections and explaining how the rules apply to the situation. Cool. So part 1. So renovation involves installing a new power outlet and lighting in a bathroom. The homeowner wants the socket installed right next to the sink. Which section details the clearance distances for electrical fittings in wet areas? So for the first 7 questions, you just need to answer which section. Yeah, it is section 6, guys. So if you're looking for installing in the bathroom, it's section 6. So sets out minimum clearance distance for power outlets and electrical fittings, and socket outlets must be installed outside a specified zone unless they have an IP rating. So right next to the sink, you'd have to put it a little bit further away just because of the IP rating, or it would have to be an automatic disconnect shaver style fitting, or inside of a cupboard. Cool. The electrician is installing a new main switchboard in a small commercial building. The client wants it placed in a storage cupboard where it will be behind shelving and stock. Which section of 3000 Part 2 outlines rules about switchboard placement and accessibility? Yep. So most of you guys got it. Definitely section 2. So general arrangement, control and protection. 2.9 is all about switchboards. So it must be accessible for operation, maintenance, and emergency disconnection. So obstructions such as shelving or stock must not restrict access, and you can't put your ironing board in front of it. Cool. Cool. So electrical supply to a caravan park. Now electrician is setting up electrical supply points for caravan holiday park. They need to ensure the supplier meets all legal and safety requirements. Which section covers specific installation rules for caravan parks? Yeah, it would be section 7. So it would have rules for the caravan parks, or basically it would direct you to which section you need to know, which standard you need to then go reference, because there's an external section for caravan parks. Cool. Equipotential bonding in a pool area. So an electrician is wiring a pump system for a swimming pool. They need to ensure that all conductive parts around the pool area are safely bonded. Which section covers equipotential bonding requirements in pools and wet areas? Yep. Cool. So section five. Yep. So section five for earthing arrangements because it's for bonding. So pools and wet areas require equipotential bonding to prevent electric shock hazards from potential voltage differences in the water and surrounding structure or equipment. Cool. So five, testing before energizing a new circuit. So a new house build is ready to be connected to the grid. The electrician must test the installation before livening it up. Which section outlines the verification and testing requirements before energization? Yep. You guys got the right section. So section eight, verification and testing. So before a new installation is energized, insulation resistance, polarity, and earth continuity tests must be conducted to confirm compliance. Built underground wiring protection. So rural property needs a sub-main cable run between two buildings and the client wants it buried directly in the ground. Which section specifies requirements for installing and protecting underground wiring? Yep. Section three, selection and installation of wiring systems. So underground wiring must be mechanically protected, so installed in conduit and follow depth requirements to prevent damage. Cool. So dedicated circuits for fixed appliances. A homeowner is getting an electric hot water cylinder installed. Electrician needs to determine if it can be wired off the existing general power circuit or if a separate circuit is required. Which section defines requirements for fixed appliance installations? Section four, selection and installation of appliances and accessories. So fixed appliances such as hot water cylinders must have dedicated circuits to prevent overloading general purpose outlets. Cool. So What I'm going to do actually is I'm going to take the other one we did, the questions that we've been doing. I'm going to put them onto the Google Drive. Make sure I give you the ones without the answers. Cool. And I'll put the link in the chat now. Just make sure anyone who has the link can use it. So it's getting a bit late. So what I'm going to do is I'm going to give you guys the worksheet. And so what I want you guys to do is to go through the worksheet as homework. And then next week, actually, yeah, I want you to go through there, figure it out. And then I will post the answers to the chat later in another Google Drive because I'm just realizing next week. So next week, guys, is our end of term test. So it'll be covering off the topics we've covered this year. So it'll be covering over legislation and various other things. So what have we done so far this term? We've looked at control circuit diagrams, faults, testing. We did a bit of lock off, tag off. We talked about the governance bodies, compliance, and 3000. So it'll be covering off those topics next week. So you'll be logging on. I will have a code for you guys to open the test with, just like we've done previously. And then from there, you guys will do the test. Once you finish the test, then you can log off and call it a night. And then we will have a 2-week break, and then we will be back for term 4. And then we will be doing the last little bit, term 4. I can actually maybe look at. So we'll be looking at magnetism and AC generation next term. That's the first topic. And then, of course, we will be doing a whole bunch of revision just before the end of year test, which is your guys' capstone. So that's all for this week. Download that test sheet, the answer sheet, quiz sheet. Have a go at it. I'm going to stop the recording now, and then, yeah, so we'll go over term 1 and 2 a little bit as well.